We know that buck circuits generally require upper trip control, and this implementation of raising its own voltage mainly relies on a capacitor, which is the bootstrap capacitor. So how exactly does this capacitor achieve its function? For example, a small capacitor is connected between the GS of the MOSFET. The MOSFET charges the capacitor when it is not turned on. When the MOSFET turns on, when the S-pole voltage increases, it will automatically increase the supply voltage of the driver above. At this time, the output voltage of the driver also increases and is connected to the G electrode of the upper tube, which means that the G electrode generates high voltage, and there is a sufficient voltage difference VGs between the G electrode and the S electrode, so that the upper tube MOSFET continues to conduct. During the charging process, in order to prevent straight-through, the IC will prohibit the upper and lower tubes from being conductive at the same time. In other words, the upper tube will be turned off, the lower tube will be turned on, and then the diode D1 and the bootstrap capacitor C1 will form a charging circuit. The input power passes through D1, C1, then through the lower tube, and finally to ground, forming a loop to charge the capacitor, so that the voltage on both sides of the capacitor is equal to the input power supply. In turn, when the current switch is turned off, the previous loop is naturally cut off, and D1 is in reverse cutoff. At this time, the capacitor will maintain a continuous voltage change, and the VC voltage will slowly become smaller, with discharge without any sudden changes. However, during the charging process, since the capacitor has been charged, the VC voltage is approximately Vin. Then the VGs of the upper tube is also equal to the input power supply, and this voltage is enough to turn on the upper tube. In this way, APWM cycle is completed, which is the charging and discharging process of the bootstrap capacitor. This circuit uses 2 MOSFET tubes, so it is very important to choose the appropriate MOSFET tube. Here we recommend the VB model VB1330, which has lower internal resistance and higher switching speed. All parameters and performance should be considered comprehensively to ensure that the circuit's stable operation and superior performance. If you have any questions about MOSFET product technical solutions, you can leave a message in the comment area. I will give you the answer here. VBsemi-MOSFET manufacturer focusing on MOSFET R&D and manufacturing for 20 years.